So, good evening, everyone. Thank you for joining this evening, wherever you are. Happy New Year, first of all. This is our first webinar of this year in 2022. And hopefully we will be able to have one in 2022 that will be in person. So let's keep our fingers crossed and hope we can be able to do that. So my name is Alvin Chin. I am the chair of ACM Chicago and also the chair of IEEE Computer Society Chicago. And we welcome you to our first webinar, which is on the great semiconductor shortage of 2021 and 2022. As everybody all knows, what happened from last year with the supply chain issues due to COVID. And we have Sharan Kalwani, who will be presenting that. But before we do, just a little bit of intros. So first of all, want to welcome members of IEEE Computer Society Chicago. So we've done lots of joint events with IEEE, and so we thank IEEE Computer Society for their support of this. Like I said, I'm the chair. We do talk similar to ACM, so we talk about software, hardware, computing, AI, big data, cloud computing, so forth. And we have our credentials there, so if you want to see us on the web, IEEEchicago.org/CS. We're on Facebook, on Twitter, LinkedIn. We have a YouTube channel. And if you want to become an IEEE Computer Society member with benefits such as getting access to conference proceedings, papers, and other types of resources, you can go to this URL. So these slides will be provided afterwards, as well as the slides for Sharan's talk, as well as the recording of this video. So that will be provided afterwards. And for those who need a PDH certificate, professional development hours certificate, that will also be made available too as well. So just a bit of housekeeping notes on that. Also as well, we also have joint events with Mid-America IT Connect group. So we thank you to Mid-America. We've done previous events when we were pre-pandemic in the Mid-America Club building, which is on the 80th floor of the Aon Center. And it's a really great building, great views if you've been there before for any of our previous events. So we do IT meetings, monthly meetings, and VJ, who is online, so he's the chair of the Mid-America IT Connect group, and I'm the vice chair. And hopefully we can be able to do something in Mid-America Club, so that would be very nice. And also as well, thank you for the main members here, which are from ACM Chicago. So for those who don't know ACM Chicago, if you're new to this, we are the Chicago chapter of the Association for Computing Machinery. So we're similar to IEEE, but we're different. We're ACM. And we also, we do monthly meetings. We've done that pretty much for almost every year now. And so I'm the chair of the ACM Chicago. We have our vice chair, Mark. So Mark is there. And also we have our treasurer, Greg Newmark. And our website is chicagoacm.org, where you can see our previous kind of meetings and other stuff regarding both Chicago ACM. And of course, you probably heard about this meeting from our meetup page. If you're not a member, I would encourage you to sign up so you will get the latest when our next events are coming up. We're also on Facebook, so you can follow us on Facebook. You can follow us on Twitter, so we tweet as well. Also on LinkedIn. And of course, if you've missed, other previous ACM Chicago videos, and this video will be posted on YouTube as well. You can go to our YouTube video channel. I would recommend you that you subscribe, so then you won't miss any of our newest events that we post there. And obviously, of course, if you want to become an ACM member, you can go to acm.org/membership. So without further ado, I'm going to get Mark, our vice chair, to introduce our speaker, Sharan Kalwani.
Our speaker, Sharan Kalwani, is an industry technology specialist with 25 plus years of experience with degrees in both engineering and computer science. He's been a speaker, teacher, IEEE leader, and author, and about a decade ago was chair of the Chicago ACM chapter from 2014 to 2016. So let's welcome Sharan Kalwani to speak about the great semiconductor shortage of 2021, 2022.
Well, nice to be here. It's been a while and haven't been to Chicago since I moved back to Michigan. I mean, I've been there, but just for a quick weekend, to attend something. But for the last 2 years, haven't been there. So nice to connect with all of you online. I have attended a few events last year online. So you guys are doing a great job. Totally enjoy everything and glad to be here to help kick off things in 2022. So let's talk about the great chip shortage of 2021. Really, 2020 should also be included because we started feeling the effects of it late in 2020, but it wasn't that bad. But let me tell you all about it. By the way, those of you on LinkedIn, this is where you can find me. So if there's any question that I didn't get to today, I'll be happy to answer it later. Let me get this mouse thingy working. So I like this little graphic because that's what's going on today amongst all the industries that need semiconductor chips in all the products, which is practically every industry out there. You'd be surprised. Things like garage door openers or Mark's LED lights or big ticket items. In my neck of the woods, work here in the automotive industry, and I'll show you pictures of cars and trucks all piled up in the parking lot, and they can't drive them because they're missing one electronic part or the other. And we use an awful lot of electronics in modern day cars. And I'll tell you a little bit more about it. By the way, if there's any question that you'd like to ask, you can put it in the Q&A or feel free to, raise your hand or something like that. So hopefully Alvin or Mark or Greg, they'll keep an eye on that in case I wander too far into the topic here. Okay, so here's a little outline of the talk. Clearly, we'll talk about what is the current state of affairs and what are the reasons behind that. And there's no single reason. There is a single large contributing reason, but it turns out a few other factors have only served to make the situation bad. Yeah, that's what's happened. And you'll be all surprised to know this is not the first time this has happened. Of course, this is the first time it's got such visibility all over the globe and affecting a lot of our lives. But we've had, little minor shortages in the past, but they were minor and for a small thing. But clearly, we haven't learned from that. So, and then we'll tell you what's going on these days, what steps people are taking to kind of mitigate, the situation. And when do we expect things might get a little better? I'm not so sure, although a lot of people are expressing a diversity of opinions out there. So what's the current state of affairs? Like I said, this semiconductor shortage actually started late in 2020, and it continues to be a crisis with us. And I call it a crisis because let me give you again the example of the automotive industry. So the average price of a car today, you could put it anywhere between $20,000 to $30,000 a new car. In the US alone, we sell anywhere between 9 million to 16 million new cars every year. 9 million in the bad years and 16 million in the roaring years when the economy is right at the top and people are spending money. So you can do the math at an average of $30,000 a car multiplied by 9 million. And if you can't sell them because of one feature or the other, then clearly, it gets people with a lot of capital invested upfront, like the manufacturers, nervous. And it's not just the automotive, several industries are affected. And because they're affected, there are queues amongst lots of consumers. Consumer here's are even, people, the large manufacturers of large capital goods, have them queuing up for items like chips, controllers, video processing cards, onboard controllers, network interface cards, all sorts of subsystems, electronic subsystems in aircraft, in industrial machinery, and stuff like that. And not to mention game consoles. I keep hearing from my kids, that they wanted to buy a new one and they found it was like almost $400 above what the manufacturer retail was costing them on eBay and other places like that. And of course, this has caused a lot of speculation out there, including, stock market fluctuations. They're very skittish, these folks, when they hear, this particular industry or manufacturer might have a shortfall of income because they can't sell it because short of a chip. They just, do a number on their stock out there. So let me share a little bit of background as to why this is all going on, or what are the variety of reasons out there. Well, it turns out that there's a combination of different events. They all sort of happened at the same time. But the primary one out here, as we all no prizes for guessing that, was due to the pandemic. That's the primary driver of it. And there were two major things that it caused, which I'll talk about in the next slide. And then around the same time, there was a trade war, as you know, the previous administration started, and it's still ongoing. It hasn't been resolved yet. And then there's a couple of other things, but the big one that I'm surprised a lot of people don't know about, but Taiwan, which supplies practically 50% of all the chips, both advanced microprocessors all the way down to little memory chips or controller chips or A to D converters and stuff like that, they had a drought, and it turns out this has a direct bearing on it. So let's go into all of these. Well, March 2020, we all had to, most of us had to stay home and work. And then we discovered that, well, things are slow on our home desktop or laptop, or everyone in the family has to, be online at the same time. So, okay, we'll upgrade their laptops, upgrade their webcams, upgrade their monitors, upgrade their desktops or tablets, get a more powerful router with at least 3 antennas sticking out of it. And then you don't want to wait for stuff to download, so you keep a copy. And if your local storage ain't enough, well, get yourself a portable storage device, keep it out there, plugged into a USB 3.0, so you can fetch it instantly. And of course, life doesn't end at normal working hours. Everyone wants to be entertained, and the kids want to play online gaming and stuff. So our usage is constant. Devices break, and they have to be replaced. And a clear indicator of this was in Q4 of 2020. When you have your Black Friday sales, Thanksgiving sales, Christmas sales, traditional computer sales, everyone was surprised. They thought, oh yeah, it might be a little bit higher, but they saw a massive 26% orders compared to the previous year. And I got a little more data comparing Q4 2021 with Q4 2020 as well. It was, the right word is there, staggering. And then all these, peripheral device makers or computer makers and associated industries, people that supplied into all others, well, they faced a, supply chain dilemma because, practically everything has some sort of embedded device in it. Yeah. So clearly, this is where things started. And here is a little bit more information, as I promised. If you go to the Semiconductor Industry Association, which is like an industry lobby group, they reported that even as far as Q3 of 2021, they saw a massive increase, about 27% a little higher than the third quarter of 2020. And there's a similar figure for Q4 2021. It's pretty massive. So everyone was taken aback, and it's just growing. And let's see, there's a little bit more to the story out there as well. Remember the China-US trade war? Well, this was early in 2020. The US government placed restrictions on a company called SMIC, which happens to be China's biggest chip manufacturer. So they supply to all of the Chinese manufacturing industries, and all the things that are exported, loaded onto container ships that are now sitting off the port of Los Angeles. Instead of a 5-day wait, they're in a 30-day wait, and it's piling up there. So they placed restrictions on them. So folks in the U.S. or government, they could not buy equipment that had chips or products that contain chips from this particular manufacturer. Well, it then forced companies all over to go to, the big manufacturer, TSMC, Taiwan Semi-conductor Manufacturing. Hey, could you supply us these chips? Or Samsung, or many others out there. I have a graph somewhere late in the presentation that shows you the relative percentage-wide share of all these folks. And the fun part is, in 2020, when they went to these companies, they said, well, we're already running at capacity. What do you want us to do? Yeah, you'll just have to wait. And that chart started the ripple chain effect all across the industry or industries out here. And that was, back in 2020. So that happened. And then Taiwan, in 2021, Taiwan had a pretty bad drought up there. As you know, island nation, and they need, all the fresh water supply they can get their hands on. And they have desalination plants as well, but that's not enough. And it turns out that the Taiwanese chip manufacturers, they consume an awful lot of water. They have to, first of all, ultra purify it so that they can produce very high category level clean rooms. You need the clean rooms to produce all those high density chips or different silicon wafer sizes. Just for example, TSMC alone uses 63 tons of water per month just to maintain their clean rooms. Whenever they do a process switch or finish one production run and they have to switch, you have to have different equipment for the different wafer size and densities. So you have to perform this. So they were asked to be a little bit frugal with their water usage. So then they push back their production schedule. And this is all happening while they have a backlog of orders piling up here. And then what I think is one of the biggest contributors also, as you know, in March 2020, because of the shutdown, lockdown, many of the car dealers, at least in the US and probably true in other parts in Europe as well, but in the US, many car dealers temporarily closed down, and they all expected that the economy will shrink. Now, all of the automakers, even based here and abroad, they've had experience with down cycles in the economy and swings like that. So naturally, these big ticket items, they don't want to have all their money tied up in all of these. So they promptly canceled orders for many of the parts, not just raw materials, steel, rubber, and other stuff like that, but even electronic parts with all the chips in there, because they all thought, well, auto sales will drop. So they, cut back massively. And again, when they told, the chip manufacturers, they retooled their stuff so they could meet some temporary demand from other industries. But the automotive are big volume stuff, so they cut back. And just to give you an idea, this is data from Deloitte and IHS. And this is at least the recent one I could get my hands-on April of 2019. Way back in 2000, if you bought a car and whatever electronics was in it, for example, automatic fuel injection, we call those ECUs, engine control units, which times the amount of fuel injected, monitors the engine, so you have your onboard diagnostics, and maybe a few other things, cruise control, stuff like that. So that had about 18% of the cost of the vehicle was all the automotive electronics. Now, if you go 20 years or more recent, 2020, this 18% is now 40% of the average cost of the car. So whatever is 40% of $30,000, that's the amount of electronics, and they cut back on it. So you can easily surmise that this is quite a bit. Unfortunately for them, or fortunately, initially the car sales did fall. But it turned out that there was a lot of demand out there because of a lot of financing that they tried to put to prop up car sales. Demand went up. Not only that, we had now a whole plethora of online car sellers. And I'm sure you've seen many of those ads out there. So people sitting at home, they say, well, we need a new set of wheels. Even though they're not driving to too many places, they said, yeah, there's good financing, let's take it. And suddenly, demand picked up. And when demand picked up, all of the automotive folks were caught off guard. Just to give you an idea, we actually joke that this is not a car anymore, it's really a computer on wheels. And some people have told me that that's what we say about Tesla. It's nothing but a giant tablet with a bunch of wheels wrapped around it. So if you do the counting properly, look at all these subsystems out here, you have an average of 1,400 chips inside the car that control everything from your airbag to the engine, the climate inside. Then you have nowadays all this advanced autonomous driving system. Alvin knows all about that. He can tell you plenty for collision avoidance, parking assist, things like that, your traction, TPMS. All of these have a whole bunch of chips controlling them. The powertrain, I mentioned the fuel injection, and then transmission, and then your lighting system, vehicle diags, your TPMS, braking assist, and not to mention the instrument panel out here with all the navigation and the driver display, sensors, and then of course, outside connectivity, over the air OTA updates, and then we all want internet in the car, so it has to connect up with the cell phone providers. Plus, there is actually a local area network inside the car that connects all these subsystems together. And they even have a dedicated one for all the cameras, the infrared, the LiDAR, and the short range, everything. So we have all of those as well. So if you count these up, that's a pretty substantial sum. And then, look at the volume and cut back on that. And you can see why this added, a sort of a big ripple effect on the semiconductor industry. And then we have the online shopping folks. Hey, you can buy this car, we'll deliver it to your house, and stuff like that. And, you can do almost everything online. And they'll even pick up and drop it off for you, even for service if you like, everything. Well, that led to a big demand. Here's a little example of just 4. Tesla, as you know, doesn't have dealers. You have to buy direct from them. Carvana, Vroom, CarSaver, and they're all pretty comparable. They'll give you a 7-day try or buy and stuff like that. And look at their market cap out there. So clearly, a lot of people putting a lot of money because a lot of volume business out there. And so this, created then sudden demand, and then the automakers scrambled back to all the chip suppliers, and they said, well, we can't ramp up and down just as easily. We've got also other orders, so everyone's got to get in line. And then let's make things a little bit more interesting or dicey. There's a manufacturer called Renaissance Electronics in Japan. At one of the factory, there was a fire. The damage was pretty extensive. So they had to gut the factory and rebuild it all over. And then, of course, make sure that everything's clean. They want clean rooms for that and stuff like that. So it took them about 6 months to get back in full production. And in the meantime, the backlog of orders kept coming in. And this is, I think, the number 2 or number 3 in all of the automotive chip suppliers. I do know they supply to Toyota, Ford, Continental, and stuff like that. And I have, stuff that I got from Bloomberg, which tracks which chip supplier supplies to which automotive consumer and stuff like that. Let me take a look at the chat out here. See if there are any questions. Okay. Let's see. Okay, there's so far nothing.
Yeah, Sharan, we're going to have questions after your talk.
Okay.
So just keep going.
Okay,
Thank you.
Let me take a drink of water. At least my water doesn't have to come all the way, stuff like that. But yes, that fire in there also, added to the headaches for everybody in this business as well. So let me, so what's the conclusion of all of this? That clearly forecasting was part of the root cause. There are other things as well. Now, we all know forecasts are not accurate, but, 1 or 2 companies trimming their forecast, we can deal with. But having something like 20, 25 plus automotive companies all scale back, well, many chip fab plants, they said, okay, we can manage capacity with some of the other ones, so let's shut it down. Now, once you shut down a chip fabrication plant, you don't start up on a dime. It takes a while to get it back up, and usually these are, continuous operations. And so you have to do a lot of things. There's a lot of overhead to starting and stopping these kind of things. And of course, the demand is for all sorts of different chips, 8-bit controllers, 16-bit microprocessors, memory chip, special ASICs, and then they're also made from different wafer sizes, as large as 300 millimeter. I have a picture to show you the different wafer size, and different factories or manufacturer use different wafer size, and the etching that they do on the chip is specific to that size. You can't just put in a smaller wafer size. The equipment is customized to that. So all of this led to severe capacity management, and because of this, there was turbulence in all sorts of industries, and we're still living with that today. Here's a little picture. This is the smallest one, the 2-inch wafer, and this is a larger 8-inch wafer. These are pretty common nowadays because the larger the wafer size, it leads to better economies of scale, so you can produce more chips out of it. And then there's even a larger one, 300 millimeter. Let's see if I have a picture. Yes, I do have a picture. And this is from Samsung, from their factory in China. So you can see this is pretty big, and that's the clean room at the back out there. And it has to pass very rigorous quality inspection. Even one flaw somewhere on the wafer causes them to reject it. So, they can't churn it out like potato chips and stuff like that. So they are trying to build more 300 millimeter capacity. This was actually a report published by the Semi-conductor Industry Association. So as you can see that they started off with a smaller amount. This is the total global in the world. And they're building more 300 millimeter fab. Sometime in 2 or 3 years' time, it'll be in the 165 range or something like that. Since this slide, there's been at least 3 other or 5 other plans announced to build 300 fab chips. And you can tell who has the lion's share of it. Clearly, it's Taiwan out here, followed by Korea, then Japan. The American share is pretty small by comparison. They are building at least 3 I know that I'm aware of, and maybe a couple more, but it's mostly Taiwan, Korea, Japan, and China that lead the world in chip fabrication out there. Here's another which breaks it down by the actual company. As you can see, Samsung, Taiwan, Micron, they're leading. Intel is somewhere out here, and UMC out here. Here's Texas Instruments. So they're on the lower end up there. And this is just for 300 millimeter. And then 200 millimeter, it's a different story out there. Infineon is a big automotive supplier. Here's SMIC. Remember that company that the US imposed sanctions on? So you can see 200 millimeter is one of the 2 larger chip wafer size. And so a lot of small controllers, they're cut out of this. So they were clearly affected. And when you take out this capacity out here, it does affect a lot of people there. And here TSMC, they don't do a whole lot of the smaller one, having moved to the larger wafer out there. So while they can do both 200, 300, the smaller ones they can't. And there's a lot of demand for these as well. For example, your little diodes or Toshiba or others. Many of these companies you may not have heard of, but they go in a lot of the consumer electronics stuff here. Okay, so like I said in the outline, this is not the first time it's happened. We've actually had little hiccups in the past. I've been around to remember these way back in 1988. There was a shortage, and Hitachi was, I think, a memory supplier then. And they actually asked their workers to work through their summer vacation, not take vacation, so that they could meet the demand. And you don't hear too much about it unless you follow the industry, but this has happened, in the past. Then again, in 1994, what happened is there was a technology change. I believe it was the 28 nanometer or 45 nanometer, so more density, and they had a tough time getting the clean rooms working to exact spec. Remember, if there's even one defect, you have to reject the lot out there. So they had to go through a few iterations before they got it right, because of the more, finer ultraviolet etching on the chips, and they had problems with that. So that introduced a temporary shortage. So after going through a few iterations, they improved the process till it was stable and fewer quality issues. So that happened way back in 94. And then Intel itself had in 2000 a little shortage as well. You might all remember a company called Gateway Computers. I remember buying one for my Gateway desktop for my kid. And they were exclusively Intel chip consumers, but because of issues at Intel, it caused them to actually switch to AMD, Intel's competitor at that time. Such was the problem. 4 years later, our telephone industry or cellular industry, they took off, and they had a lack of CDMA chips. CDMA, like GSM, uses slightly different algorithms and technologies and frequencies, and so they had an issue with CDMA because of the phone companies, many of them, getting into the market and manufacturers. So at that time, and it didn't affect the computer industry, but the telecom industry, yeah, it did. And you need those also in the cell phone towers as well, yeah. And then 7 years later, we had Fukushima, which occurred. And around the area where that is located, there was a number of Japanese memory and LCD panel display manufacturers. So they were impacted. And a lot of the Japanese manufacturers had an issue with that. So they had to, relocate elsewhere. And Toyota was one of the biggest consumers of the factory output from the Fukushima. They learned their lesson. So they actually built a 2-year supply with other manufacturers in Japan for whatever memory they needed in the onboard controllers. And in fact, in the US, Qualcomm was also affected, and they actually released a financial statement or press release for their chip, the Snapdragon chip. So Qualcomm manufactures some of the chips, some of it has other people fabricate for them, and I'll share that information with you. So this has happened in the past. Here's the breakdown of chip designers like NVIDIA, AMD, Qualcomm. They design chips, and then they have folks like TSMC manufacture it for them, maybe with their 200 millimeter or 300 millimeter wafer process. And they can do a little bit of their own manufacture, but maybe with some of the low cost items that they can do. And this represents the volume of the business they do with TSMC. And here is, like, for example, Qualcomm, the chips they manufacture goes into Apple, in Samsung, and the purple circles out here, they are for the automotive. I happen to know a lot about that because that's what we do out here at work. So we use a lot of Qualcomm chips, automotives out here. Not so much Broadcom, they're used more in routers and stuff like that. NVIDIA we use in servers and stuff, as well as in automotive. So here's a few purple dots there. And AMD, not so much, although they're trying to make a big push to have Alexa-like devices inside newer cars as well. So you can do voice communication and not drive. But this is data from 2020. So TSMC is a semiconductor company or fab, and these all are designers, and they have these guys manufacture it for them. TSMC makes for other people as well, folks like Texas Instrument. You can clearly see it's by the volume out here. STM, NXP is also a big automotive supplier. That's why you see a lot of purple out here, as well as Renaissance. Remember the factory that had a fire? They supply to Toyota, Ford, Continental, NXP also as well. I know they supply to many other big name manufacturers as well. So all of this is stuff from Bloomberg, publicly disclosed stuff. So you can clearly see, it's all spidered all over the place. And if TSMC sneezes, all of these other guys catch a cold. So that's what's happened here. And here's the big picture. TSMC, they really, do about 50% of the entire chip supply in the world, followed by Samsung at about 4 billion, 1/3 of TMC. And then UMC is also Taiwan. Global Foundries is a US-based company, but I think they're now owned by the Europeans, somebody in Europe. And here's SMIC. Remember the Chinese company that got sanctions placed on them? So they do about 1 billion, and it's a lot of the lower density, high volume chips. So it's not just the dollar value, it's also the volume that they do that got infected. And there's some couple more Taiwanese companies here, VIS and others up there as well. So you see the makeup of all of these out there. And it has a pretty big impact here. I'll just skip this 200. I think I already shared an earlier table with you. So this was from a past inclusion. And a lot of folks ask me, what industries use chips? Well, practically all of them. At the bottom, here's the automotive. And I think I shared a graphic with you, 18% to now, almost 30% out here. And this is in terms of revenue. And then this particular is the computer industry, everything servers, tablets, laptops, desktops, basic anything to do with computing. And then your consumer electronics is here. And this is the military part in green. And then your wireless communication, all your cell phone providers and stuff like that, the people who are touting 5G and stuff like that, they're a big consumer of things. So practically everything we do in life, whether we drive a car or operate equipment or talk on our cell phone or use any kind of consumer electronics, they need all of this, and it's pretty big. The need for chips out there. Now here's a little bit more data, and I have two graphs. One I'll show at the end, but again, this has happened in the past, although its duration was very short-lived. So this is a thing from Susquehanna Finance Group. I can never pronounce that name properly, but I hope I got it right this time. So this is the average time that they have to wait, the lead time for chips. And back in February of 2018, this is about 14 weeks. But notice it dropped, pretty quickly. So in about a year's time, it dropped. And it took maybe a little 2 years to reach this kind of peak. And then we've been sort of languishing at about 10 plus weeks for quite a while since July 2018. And it wasn't too bad. It was starting to climb up a little bit, somewhere out here, March of 2020, but it wasn't too bad. Maybe 12 and a half weeks versus 10 and a half weeks. But then all of a sudden, after the fourth quarter of 2020, when we had that 26%, staggering increase, it went from, little over 12 weeks to about 15 weeks. And then in January of 2021, just within the month itself, it climbed by a whole week to 15. And I have another graphic that shows we've exceeded this number. And if I don't show it, do remind me. I will share that with you. But this is much higher than what it was in July 2018, and we're now well past that. So I hope to show that to you a little later. So what are we doing to mitigate it? Well, we hope people have learned lessons, but we'll find out in perhaps 2 years' time, but we'll have to live with it for a while. As with everything, whenever you have shortage of any product, it's all demand supply stuff. It does take time. My advice to a lot of folks is that you ought to be learning from it. And for the semiconductor, the TSMC, the Samsungs of the world, there is no simple answer to this. What I would tell them is that, well, build more fabrication plants and in different geographies as well. So you don't have to, wait for a big container ship to show up, load it all up, and then send it across. Try to do that. So if there's maybe a calamity in one geography, I don't know, underwater volcano, then you won't be affected, in other parts of the world. But it's not an easy answer because constructing a semiconductor factory costs several $billion. There's a famous law, I think it's called Rose's Law, R-O-S-E. Rose was a East Coast financer just before the Silicon Valley started its big boom. And he had gotten in touch with folks in San Francisco, and he invested in all of these semiconductor, Fairchild, National Semiconductor, building their fabs. And he observed over the years that just like Moore's law, every 5 years or so, the cost of making a silicon manufacturing factory doubles. And it's now almost $2 billion or maybe more to create a new semiconductor. $2 billion is no small amount, and people have to think twice before investing that kind of money just to build more fabrication plants. So it's a tough call for them here. And then those people who design chips and then give the blueprints to, or in the semiconductor industry, they call tape out. They cut it onto magnetic tape and send it across. They ought to learn by having multiple sources. Often they sign single source deals. Okay, we'll buy all of our chips from Intel, like Gateway did. And if Intel has a problem, then, well, we have a problem or they have a problem. They have to do multiple sourcing. Don't rely on also any single, advanced, 7 nanometer chip or something like that. Have designs or products that can use other kind of low density chips and stuff like that. So you can switch suppliers and things like that. And maybe the semiconductor industries, they can license their product, get royalties, and have somebody else manufacture for them. As a matter of fact, you may not know this, but Intel has actually asked TSMC to design or manufacture some chips for them because they're putting in a new factory and it'll take time. Whereas for that particular wafer size, TSMC has some capacity. So they're doing some cross licensing as well because of different manufacturing processes here. So what do we see today? Well, I'm going to share with you pictures of parking lots filled with Cadillacs and giant pickup trucks and stuff like that. Pickup trucks that are used for commercial purposes, which drives the economy. They are actually automotive companies that have reported losses because they couldn't sell their cars. And I'm sure you've heard of this. Used cars are actually now, more valuable than what you paid for it because the demand is high. And of course, I heard from my kids about Xbox and PlayStations. They've been wondering why it costs more than it used to. Yeah. So here's a picture from Interstate 96. This is actually a municipal parking lot. And these are Ford F-150 trucks. This is from the Detroit Free Press, April of last year. And they're all waiting for one or two controller parts that the manufacturers, they had a single source, and those folks are stuck. So they have to wait sometimes as much as 3 to 4 months before they can put in the part and then take the car or truck for Q&A before they send it to the dealer. You can see the interstate out here right next to it here. Here's another picture from Lansing, Michigan. And this is a General Motors assembly plant. You can see some Cadillacs out here. And then these are Camaros out here. You can see the spoilers. Basically muscle cars and luxury cars, both high profit margin, products that are sitting on parking lots. Typically, it'll be about maybe a third of what you see in that picture. So, and this is a month later. That was in April. This was in May, also from the Free Press here. And then I took some snapshots from industry news as well. As you know, Ford has a iconic pony car called the Mustang. They now have an electric version of it, EV version of it. They've told their customers there's going to be delay. Maybe earlier you would get it in a week, a year ago or something. But today you have to wait 6 weeks for that. And folks like Nissan, they have an assembly plant in Tennessee. They get some of their parts from Malaysia. And because of a COVID outbreak, they faced issues. And it's the same story in Europe. Volvo had to stop production. Even before it got to the parking lot, right there in the assembly line, they stopped it because of chip shortage. And China's not immune to it itself. And they've reported issues because of many different factories getting hit with coronavirus. They have very severe lockdowns in China. So it does affect them economically, no doubt about it. And then in Q4 of last year, Toyota, Honda, Hyundai, all of them said that their production has cut down, some of them as high as 40%. And so their income flow will be a little lower. Here's something from the CIO Journal or Wall Street Journal. He talks all about all these issues out there. And like myself, it's going to last for a little while. And long term is more than 2 quarters for these guys. I'd say at least a year. And then, like I said, GM actually reported a net income drop, and they're all scrambling to try to do something about it. And it's not just the automotive. Like I said, every industry is affected. This is Dante AV. They are a what do you call distance learning to universities and corporate offices. They provide video conferencing facilities, distance learning. Even they have told their customers that, you just got to wait. We'll take time to deliver it. Yeah. And even cell phone providers have been impacted. This is from fourth quarter last year, where they said that actually instead of 1.1 million units, which was in 2018, it's going to be somewhere between 1.4 million units. And smartphone sales for them is also a big ticket item, several $100s. So there's a shortfall out there. Yeah. And not just the automotives, but all the suppliers to the automotives, they are also being affected, even if they don't use chips. The products they make that go to the automotive folks, copper, steel, they have to take cutbacks on their orders as well. So it rattles everyone all across the board. Now, remember, I told you maybe about 10 slides ago, the wait was something like 15, 16 weeks. Well, this is new data from the last week of December, and it's now gotten to about 22 weeks. And they think it might hit 25 weeks. We don't know, but it certainly is at 22 weeks out there. So instead of the 13-week, 14-week, it's now climbed up to 22 weeks, which ain't good, So it affects everyone. And this is the same data that was published in Market Watch. And so everyone is scrambling, trying to do stuff, but it does take time. And they have to worry about a lot of things. If they over provision, then if there's an oversupply, there'll be a drop in prices, and that can affect the bottom line. So they're worried about it. And if they, again, fear that the global economy will take another massive hit, we don't know. If it does, then what are we going to do about that? The only folks that I see that don't seem too perturbed by this are the defense folks, but they've made special arrangements long time ago, carve out the supply, doesn't go to anybody else, and it's exclusively for them, and they pay, a proper coin for it. So they also saw a little bit delays, not much, but they think they'll be well past it, by the end of this year. Here's the article link that discusses that in detail. Well, like I said, several suppliers are doing stuff. They're manufacturing fabrication plants. And of course, all the automotives, they are beating up on TSMC so much that TSMC said, okay, we'll give you priority on stuff like that. A German supplier, Bosch, said, forget it. I'm building my own fabrication plant. And they invested $300 million in Germany to make their own chip manufacturing to supply exclusively to them. So you've got automotive suppliers getting into the chip business here. I think I already covered this one as well. Here's Land Rover. that actually reported a loss because they just couldn't sell many cars, maybe a small fraction, because they have electronic subsystems. Here's the defense industry link that I mentioned. And this is Texas Instrument. They're building 2 plants out there in order to take care of it. My personal view is that this is actually an opportunity for all of us to catch up out here. And I think the administration is putting some money behind this. We hope it'll work. So as we know, our share of worldwide industry fell. It's pretty low, but this is an opportunity to catch up for everyone in the electronics industry. So let's see if they actually do it. Right now, it's just a piece of paper. And hopefully, from the 30% we were today to 10, 20, 12%, it'll grow back up. So with that, I will conclude today's talk. Thank you very much. And this is just some news I saw a couple of days ago. Intel's investing in Ohio. I don't have any details. TSMC is actually building a fab in the US, but it'll at least be 2 years before we get some product out of them. So with that, thank you very much. And I hope you enjoyed it. Yeah.
We have some questions. The first one is from Akio. There are many, many chip manufacturers with different products applications. Are they all having a shortage? If yes, why?
Some are not. It depends upon who their supplier is, what sort of wafer size they're using, what technology, whether it's 45 millimeter, 20 nanometer, stuff like that. So it's different answers for different electronic products manufacturers. But by and large, most of them are seeing a little bit of slowdown. Some may be 14 weeks, 15 weeks, depending upon the complexity of the chips they use. Some a lot less. So it's a kind of like diverse answer across the board.
This one's from Tracy. Two questions regarding water. Besides the overwhelming amount of water, doesn't it also produce a lot of toxic wastewater? And are there new approaches to manufacturing in the future that does not require so much water and that is more environmentally friendly?
Okay, to the first part of your answer, yes, there is, the wastewater they produce, they can't throw it back in. They have to treat it before disposing of it. I know Taiwan is a little bit careful about that. I don't know about China, what they do out there. But in the US, we have the EPA and folks like that. Europe is also very specific. So they do have to treat the water before they dispose of it. Now, as far as more environmental friendly manufacturing processes, I'm not aware of any, but that's a very good question. It's something that maybe I'll look into, but I'm not aware of any improved methods for that.
I'm going to combine two related questions. They're both regarding an invasion of Taiwan. Is this a nightmare scenario if China decides to invade Taiwan? And if China was to seize direct control of Taiwan, having control over the fabs, what would be the impact worldwide?
Let me say, I think it was in the description. I'm not a soothsayer, and I'm certainly not a political scientist. I do know that China has been making noises. I will tell you, as far back as the 1960s or even before that, they've never considered Taiwan to be a separate country, and it always rubs them the wrong way. My dad was a retired diplomat, so I did get a chance to travel to many of these countries and see at firsthand how the people see and think. I think China will actually wait to see what's happening with Russia and Ukraine. And if they don't see too much blowback from it, it will make them bold enough. Now, having said that, I don't think they will actually invade Taiwan. They already have business ties with them. They've been doing saber rattling for a long time. And they also understand that if they do invade Taiwan, it'll upset financial markets all over the world. They may not have customers to sell if they carry out such a step. So I think for the foreseeable, maybe 2 to 3 years from now, I don't see China invading Taiwan for the time being, but they play a long and patient game, and we'll have to just wait and see, what's the situation in the world at that point in time. So clearly, these sort of things are very hard to predict. So I say that with a disclaimer. I hope that answers your question.
It's a good answer. And for our last question from Stephen, are the USA fabs that were previously owned and operated by Motorola, Intel, and others still in operation, or were they shut down?
Can you repeat that? I'm sorry.
Okay. The original factories, semiconductor factories in the US that were previously owned by companies like Motorola, Intel, and others, do they still operate, or were they shut down?
Well, as you can see, the US share has declined a great deal because they found it cheaper to have somebody else fabricate it, and they shut down many of their chip fabrication factories in the US. So we only have a handful. If I remember correctly, I had a map of these. Let me go back to that map and share it. So can you see the screen? So the light blue states that's where you have a concentration of chip manufacturing. And it's really a very small handful. Some Intel, some Qualcomm, some United Foundries, and a few here in Texas, and then a couple on the East Coast. So there isn't a whole lot. Many of the larger fabrication houses in the US did shut down. Now, I don't think they're going to start up again because it's very capital intensive, but only the existing ones like Texas Instrument, Intel, and one or two others who have fabs out here, they're putting some amount of money into building new ones or retooling some of them. Let me see, I had one more slide that was, oh yes, this particular one. Qualcomm thinks that they'll be able to address it with their capacity out there. We don't know that for sure, but we'll wait and see what happens. And here's another one. This was in the last week of December from Wall Street Journal. You can see Texas Instrument, Analog, Infineon, STM. They're the smaller ones. Their stock is climbing, and they might put in some capital out here for building up. But I don't see, too many fab houses, coming up. Whatever was shut down in the last 30 years, they haven't restarted. There's also a talent problem as well. So that's another problem.
Some people always say that these foreign countries took the business from us, but it's really in many cases the American capital that chose to move the
Correct.
manufacture elsewhere.
That is correct. They didn't steal anything. We just, the businessmen here, they made that decision.
All right, great. Well, thank you very much, Sharan, for this wonderful presentation. I've put the poll up there, so if you haven't answered the poll, please do so. This will help us to improve our future webinars and to decide, if we, how to start up a in-person meeting again if there's a lot of interest for doing so later for this year. All right, so we have our next talk webinar next month. So maybe, Mark, can you go ahead and explain this?
Sure. We know that our audience with their various professional, academic, or project interests always want to know about what's coming in computing. And thanks to finding a great podcast, which is listed on the Meetup site for this event, we found a great speaker, Brant van de Vender from the Pacific Northwest National Laboratory with a talk on A Nuclear Physicist's Guide to Quantum Computing that I know that everybody will want to attend because quantum computing is definitely interesting. It's coming and you need to know about this. Make sure to sign up for this now at our meetup site for Brand Vendor, A Nuclear Physicist's Guide to Quantum Computing. That's next month on February 16th, 2022 at our regular time, 6 p.m.
Yeah, thank you very much, Mark, for that. And yeah, please attend. This is the next wave of computing. After we have Moore's law and traditional computing, and so quantum is the next era, and it's generating a lot of waves now these days. So yes, please attend and sign up for this event. And like I said earlier, all our previous events are also available on our YouTube channel, so please subscribe. You can see some of the talks that probably some of you have also attended to as well. So if you missed any of the talks, or you want to even see this talk that we have right now, which will be posted up there later. And of course, we're always looking for more volunteers. So this is a really great way to help, back the community with your skills. So if you have any, any type of skills in writing or in planning, videography, audio and editing, or working with future speakers and topics and networking, please reach out to us. I think this is a great way to get to know the community, help the community, and help build interest in computing, so we can be able to continue the high quality that we have here for ACM Chicago webinars. And of course, we are looking for also for more speakers and topics. So if you have an interesting topic and you want to have a venue to go ahead and talk about it, come to here and just email us, vice chair or chair@chicagoacm.org. Like I said earlier, a copy of the video recording, the webinar slides, the introduction slides, and of course, if you need to have a professional development hours certificate, that will be provided. So check your email in the next couple of days and you should see all that information. All right, so I know it's a very, very chilly night in Chicago. So stay healthy, stay warm, stay safe, and have a good rest of the evening. And we'll talk to you in our next webinar. So everyone take care and have a good night.